functions. Okay, so polynomial functions is just a big word for what we've already kind of just done. Those things that you just factored were polynomial functions. They were specifically quadratic because they were to the second power. But polynomial functions is just functions that have your variables in it and adding or subtracting individual monomials, okay? And so it gives you this long definition, p of x equals a sub n, x to the n plus a sub n minus 1, x to the n minus 1. All this means is it's a function that starts at some x, maybe x to the 5th with a coefficient, and goes down x to the 4th, x to the 3rd. It doesn't have to have each one, but then you typically have like plus a constant at the end. That's all that's saying for a polynomial function. Standard form of a polynomial function does highest to lowest, okay? So standard form is going to take your x's highest degree, meaning highest exponent, to lowest exponent, meaning your constant is last. That is standard form. A couple of terms here that you want to know. Leading coefficient. That is the number in front of your highest exponent. Okay, so the x cubed is my highest exponent here. The 2 then is my leading coefficient. This is a cubic term. Cubic, because it's to the 3rd power. Quadratic term, that's the 2nd power. Linear term, that's your 1st power. So think about the equations we've talked about. Linear equation, y equals mx plus b, x to the 1st power. Quadratic equation, ax squared plus bx plus c, that's to the 2nd power. So that would make sense that the 3rd power is cubic, okay? It's just following your, basic, probably Latin roots of your numbers there, okay? Your constant term, that constant is the guy that does not have a variable, and this whole thing is your polynomial, all right? We have different pieces of polynomials. So the degree of the polynomial is going to be your highest group, okay? Your highest group. A constant then, the coefficient here is 6. The variable is technically x to the 0. So that's why your constant has a degree of 0. A linear has a degree of 1. Quadratic has a degree of 2. Cubic has a degree of 3. Quartic, quintic. And then at some point, they're just like the nth degree. Like there is no one for 13, right? If it was that high per se, you would just say it's degree 13. And I don't actually make you name these. I want you to recognize the normal ones like linear, quadratic, and cubic. Those are the ones you're going to run into most, okay? After that, I'm just going to say what's the degree, pretty much. Name the degree, and then the number of terms. The terms are how many monomials you have. You have 1 term here. You have 2 terms here. You have 1 term here. You have 3 terms here, 2 terms here, 4 terms here. Okay, so terms is how many you're adding and subtracting in between. There are some that, again, monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. And after that, they usually just say 4 terms, 5 terms. Okay, so typically they just want you to know up to the 3 point. All right, questions on that? Classifying them. So when you classify a polynomial, the first thing you need to do is make sure it's in standard form and that you've combined any like terms, all right? So you don't want to classify it until you've combined all like terms and put it in standard form. So for this one, standard form here, I'm going to say 5x to the 4th minus 7x, all right? The degree here then, so now I can determine the degree. That's going to be 4, the leading coefficient. That's going to be 5, right? Number of terms. Well, that's going to be 2, which is a binomial. All right. So once I put it in standard form, I can easily kind of pull out different things. I do not have a constant. Technically, I guess it would be 0, but I don't have a constant here. It's just a 2-term polynomial, which is called a binomial. For the next one, I'm going to put it in standard form, 3x cubed. The next one's going to be positive x squared. Then I have 2 that just have an x. I want to combine those. Negative 4 positive 2 gives me a negative 2x. Now I can decide what type it is. Well, it's a degree of 3. It has, so this is going to be a cubic function. It is terms. Once I've combined them, you can see I only have 3 terms. So this is a trinomial. Leading coefficient, if I wanted to do that, is 3 as well. All right, so you want to make sure it's in standard form, highest to lowest, and that you've simplified it, combined any terms that are alike before you start naming what's going on, what the degree is, etc. All right. I do want to point out, though, You should start recognizing some of these, all right? The linear and quadratic we have done. Linear is a line, hence the term linear. Quadratic is a parabola, which we've done a lot of work with over the year. All right, and so you should recognize these. Cubic changes, and it kind of depends on what's going on. If you have just a straight x cubed function, it's going to just do something like that. If it has other terms within it, so if it's just x cubed with nothing else, it's going to be this just swooping type graph. If you have an x cubed, then an x squared, and there are reasons in how it turns, and we'll talk about those later. But your other ones will kind of move and change depending on what other things you have after it. All right, let's go to section 2. Page 307. So just some terms here. Prime factors. This is something we learned back in probably like 5th and 6th grade. I don't know where y'all learned prime factorization. Prime factors means that I am taking a number and I'm breaking it down as small as I can get it into numbers that can't be broken down. 6 breaks down to 2 and 3. You can't break those down anymore. We're down to prime numbers. Hopefully you know the term prime. With polynomials, you can break it down to linear factors, meaning you're breaking it down to factors that have a degree of 1. Most of the time you can break it down into linear factors. Sometimes you get stuck, especially if you are staying in the real number world and not the imaginary number world. Because you could potentially have like an x squared plus 2, which is lending itself to an imaginary number. But for the most part, you can break these down, and what we're going to be doing is breaking them down into linear factors, also known as factoring, okay? Now, we have done factoring of trinomials. Trinomials, quadratics, all right? That's what you did for your bell work at the top of this page. So now we're going to look at other forms of polynomials from linear factors, getting it into a polynomial term, and then from polynomials into linear factors. So let's look at this first example here. Write the expression as a polynomial in standard form. And they have given it to me in linear factors. It would be if I had said, well, here are your prime factors. I want this just as a composite number, okay? Well, you would say, well, 2 times 3 times 3, right? And so you would say this is 18. And so that would be the composite of those 3 primes. That's what we're doing here. We're taking x plus 1, x plus 2, x plus 3, and we're giving it in polynomial form. Well, the way you do that is just multiplying, which is foiling and then distributing, right? Because it's multiplication, just like with this 2 times 3 times 3, I could say 2 times 3 is 6, 6 times 3 is 18. I actually probably in my brain did 2 times 3 times 3, which is 9 times 2 is 18, right? And so order does not matter. It is all multiplication. And there are going to be times when being strategic with your order is important. So if I had an x plus 2 and an x minus 2, that's a special case. That's going to be x squared minus 4. I don't even have to FOIL that guy because I already know that's a special case. I'm going to group those two together. Anytime I have conjugates, right, where you have a plus and a minus of the same exact terms, I'm going to start with those because that's an easy, I don't even have to do it. I can do it in my head, right? So it is, you can be strategic in how you pair them up. And we will see that in some of these because it's all multiplication. In this case, I don't know that one's any simpler than the other. For these purposes, we're going to do it like they did in the book. And they just combined the last 2 here first by foiling. So they left this guy alone, right? X and x, we got x squared, x and 3, 2 and x, and 2 and 3. And then, of course, before you FOIL that, and technically it's not foiling, you're going to be just repeated distribution here, you want to combine them, right? Make this group as simple as possible before you do anything else. So let's go ahead and combine those guys there. We have x plus 1, we have x squared plus 5x plus 6, and then you're just going to distribute your x to all of them. We have x cubed, 5x squared, and 6x. And then, of course, distribute your 1. 1's nice and easy to distribute. We just have x squared, 5x, and 6, right? And then one more step. They want it in standard form, meaning I need to combine my like terms. So what combines? X cubed doesn't combine with anything. Squared, we have these two guys. To the first power, we have 6 and 5. And then the 6 doesn't have anything to combine with. So that's not very pretty. This is my answer here. Those linear factors give me that polynomial. It's a degree 3. Very simply, if you have an x and an x and an x in your original linear, it should be to the third power when you get done with this, okay? And so it's a quick and easy check that you did something right. And then your 1 and 2 and 3 multiplies to 6. You'll see that pattern as well. All right, any questions on that? So go ahead and do that one. So now we're going to go from polynomial form to factored form. Now we've done this pretty much, and they're basically just giving us a cubic, but they're giving us a cubic with a common factor. So anytime you're given anything to factor, your very first step is to get out a common factor that is common to all three terms here, or all terms that you have. So we're going to look at the numbers 2, 10, and 12. Obviously a 2 can come out. And then x cubed, x squared, and x, you want to take out your lowest, which is just x. And then we're going to have something very simple. We're going to have our x squared plus 5x plus 6. And factors of 6 that add up to 5, that's 2 and 3. So we're going to leave the 2x out here. We're going to break this down to x plus 2, x plus 3. Right? And then this is factored form. Now you can check it by FOILing and distributing. But your answer here is they want it in factored form. So we are going to make sure that just like we did when we have just quadratics, right, that we do the same thing here when we have higher as well. And so we're going to do bigger ones, but for the most part, we are going to look at common factor. Can I just straight factor it? And then when we get to ones that we can't, we're going to throw in some new methods here. All right, so go ahead and just quickly factor that. So some more terms here a little bit. We have the term relative maximum and relative minimum. We have the term relative here because this graph is infinite and it keeps going. So if it were the highest point on the graph, we would actually use the term absolute. But these are relative maximums and relative minimums. So with parabolas, we actually had absolutes, right? When you have a parabola, if it's pointing upwards, then your vertex is the absolute minimum. Like there is nothing smaller than it. But you can see when you have turns in the graphs, they are a relative. Relative to the points around them, they are a max or a min. And so you'll see that while this is obviously not the highest point on the entire graph because this guy goes infinitely, he is a relative max. So he is a turning point in the graph, and compared to the points around him, he is a high point. He is a low point. Think of it like a roller coaster, the base of the roller coaster, the peak of the roller coaster. You have several of those within a roller coaster often. And so those are relative maxes and mins. And then other terms that we have talked about, intercepts. Intercepts are where they cross an axis. These particular ones are x-intercepts, and of course this guy is also a y-intercept, okay? You can have multiple x-intercepts on a function. It doesn't matter how many times it crosses the x-axis. For a function, you can only have one y-intercept because if you had multiple, it doesn't pass the vertical line test. It's technically not a function, right? So you'll typically have one y-intercept and then possibly many x-intercepts. Now, you might necessarily have either. You could never cross the x-axis. You could never cross the y-axis. It can happen, but at most one y-intercept, a multitude of x-intercepts are possible, okay? Another term for an x-intercept is called a zero of a function, okay? So Here it says, recall that x-intercepts are also called zeros. This is the term you will very often see. So if it says find the zeros of the function, what it's actually saying is where does the function equal 0? That's also another way of saying where does y equal 0? And it's also another way of saying where does it cross the x-axis? Because anytime y is 0, you're crossing the x-axis. So another way to say that is where are the y-intercepts? So you could see, and so we have zeros, x-intercept, and we have where y equals 0, whatever it's going to say, they're all the same thing. It's where it's crossing the x-axis. Now, when they give it to you in factored form, well, that's really simple. If they want to know the zeros of the function, where y equals 0, well, y is going to equal 0 anytime any of these factors equals 0. Well, where does x minus 2 equal 0? Well, that equals 0 when x is 2. Where does x plus 1 equal 0? Well, that equals 0 when x is negative 1. Where does x plus 3 equal 0? That's when x is negative 3, right? Pretty straightforward. So when they give it to you in factored form and say find the zeros, you're literally just setting each group equal to 0. The only time I see people mess this up is when there's an x in front, okay? So don't forget that if it has a variable, that is a factor. So this one would have x equals 0 and x equals negative 2, okay? If it's a number in front, that's not a factor. It's technically a factor, but it's not one that you're going to set equal to 0 because 2 can never equal 0, okay? So just pay attention when you have something just on the outside of your parentheses. If it has a variable, you also have to set that guy equal to 0 as well. It is one of the factors, all right? So find the zeros of this one really quickly. So I want to point out a few things about reading your instructions. If they were to ask for all the linear factors of an equation, they are looking for this guy right here, your linear factors. If they are asking for zeros, they are looking for these guys right here, okay? So know the difference in what your question is asking you, all right? Make sure you answer the question. There are going to be times when it asks for zeros and you have to factor it first, and then set those factors equal to 0, right? But just read your instructions and make sure that you are fully answering the question and that you know what they're asking for. All right. So this is called the factor theorem. It's at the very bottom of page 309. The expression x minus a is a linear factor of a polynomial if and only if the value a is a 0 of the related polynomial function. So the expression is a linear factor only if you set that equal to 0, it crosses the axis. Now, why is it telling you that? It's just telling you that because it's kind of a back and forth. If you think of geometry like converse, if you factor it and set it equal to 0, you get your zeros. If you have your zeros, you can put them into factor form and find the polynomial, okay? And so they've said write a polynomial in standard form, and instead of giving you the factors, they've given you the zeros. They've given you negative 2, positive 3, and positive 3. You'll notice when we had the factors, we had to set them equal to 0, and they ended up being the opposite, right? So if you had a factor of x plus 5, your 0 is negative 5. If you have a factor of x minus 2, your 0 is positive 2, okay? Because to set it up into linear form, you're going to say x minus whatever your 0 is. So x minus a negative 2, that would be your linear factor for a 0 of negative 2. X minus 3, that would be your linear factor of positive 3. X minus 3, that would be your linear factor of positive 3. And so it basically switches signs when you put it into a linear factor or when you take it out to find the 0. It's going to switch signs. So if they want you to write the polynomial given the zeros, just like the first one, they wanted us to write the polynomial given the linear factors, you have to set those zeros up into linear factors first. So I'm going to say, well, I have x plus 2, x minus 3, x minus 3. Now this is just like example 1. They want it in standard form, FOIL it. That's what you need to do if they give you the zeros. And so I'm going to FOIL it. I'm actually going to FOIL this one first here. So I'm going to take the x minus 3, that's a special case. That's going to be x squared minus 6x plus 9. And then I'm going to distribute this guy here. So I'm going to distribute my x through. And then I'm going to distribute my 2 through. And then, of course, just like we did on example 1, combine your like term. X cubed, we have negative 6 and positive 2. Positive 9 and negative 12, and then the 18 will not combine. So when it gives you your zeros, just put it into linear factors and FOIL. That's all you're doing. Put it into linear factors and multiply. So for B, they want, it looks like basically the same ones, negative 4 and negative 2, obviously. We have those. But then they have 0, okay? So if I were setting these up, I would say, well, that's x minus a negative 4, x minus a negative 2, and then x minus 0. All right, I'm going to write that guy a different way. How do you think I'm going to write it? Just x, right? So we're not going to FOIL the 0. That doesn't make sense. So anytime you have a 0 as your 0, that's not confusing, it's just x, all right? It's just x. So basically this guy is going to look like this, right? And we already did the, well, I guess we didn't do that. So, you know, you're going to have this, and then we're going to distribute just an x to it. Right? So anytime you have a list of your zeros and one of them or two of them or however many is a 0, it's just x, right? Because it's x minus 0. And so anytime you see that as one of your zeros, it's where you had an x completely on the outside that you're going to distribute later. Multiplicity. Well, polynomial functions example 5 has 3 zeros. It only has 2 distinct zeros, negative 2 and 3. So when we did the example, they gave us negative 2, 3, and 3, right? The example right above it, negative 2, 3, and 3. 3 was listed twice. And so basically it has 2 distinct zeros and one that is repeated, okay? We have a repeated 0. A repeated 0 is called a multiple 0. A multiple 0 has a multiplicity equal to the number of times it repeats, okay? So they gave us negative 2, that was not a multiple 0, and then they gave us 3. So you can see it listed negative 2, 3, 3, or sometimes they will say, my zeros are negative 2 and 3 with a multiplicity of 2. All right, this means the same thing as my zeros are negative 2, 3, and 3. 3 with a multiplicity of 2. How many times you repeat that particular 0, okay? So that term multiplicity just means that 0 is used more than once, okay? That 0 is used more than once, all right? So it says in example 6, find any multiple zeros of this particular function. So we are going to factor it and find our zeros just like we did a couple of examples ago. We're going to take this common factor. Well, the numbers don't have common factors, but the variables do. We can take an x squared out. We're left with x squared plus 6x plus 8, factors of 8 that add up to 6. We have x plus 4 and x plus 2, right? And then we look for our zeros. Well, we obviously have a 0 at -4 and -2. And then you see this guy. It's technically two x's. We have an x times those groups, right? So we actually also have, remember we set this equal to 0. We have a 0 at 0, but it happens twice. It happens twice, all right? So if I were to list my zeros, I would say -4, -2, and 0 with a multiplicity of 2. The x happens twice, x and x, because it is x squared, all right? This would be the same if you got x minus 2 as your factoring. You would have 2 with a multiplicity of 2, okay? So anytime you have repeated factors, you're just going to list that 0 multiplicity of 2, all right? So go ahead and do check understanding number 6. Again, this is on a test or quiz. Your instructions could say this multiple of ways. Equivalent statements about polynomials. -4 is a solution to x squared plus 3x minus 4. If I plug in -4, that will be a true statement. You will get 0. -4 is an x-intercept of the graph x squared plus 3x minus 4. -4 is a 0 of y equals x squared plus 3x minus 4. And then x plus 4 is a factor or a linear factor of x squared plus 3x minus 4. Those are actually all telling you the same information. They're just saying it a different way. So pay attention to what it's saying, because a question could say, find the linear factors, find the zeros, find the x-intercepts, solve. Okay? So all of those would actually be the same answer. You would get -4, -4, -4, or x plus 4 if you were doing linear factors.